Hello, I'm Barry Sullivan, Program Director for the Electrical and Computer Engineering Department Heads Association. It's my pleasure to introduce a spotlight presentation from Renesas and BNS Solutions presented by Vin D'Agostino.
Good morning. Thank you for attending the session and your enthusiasm. I'm one of the few people standing between you and lunch, so I appreciate your being here. I am incredibly excited about embedded systems, have been ever since I entered my career in, 1982. And I have an older cousin who went to law school, and he became a county prosecutor, and we were talking about our jobs, and he said, you know, I like to think I do God's work. And I said, well, I like to think I do God's work because I'm shaping the world around me. So I think that embedded systems have, over the last 10 years, taken the place of mechanical systems that people never thought would ever happen. From BNS Solutions, we are a small design consulting firm. We work with a lot of different companies, and we have a lot of customers who have been dragged kicking and screaming into the high-tech world because it's now cheaper and easier and more flexible to make a timer with a chip and a display than a spring and a plastic knob. So some of the things that we see, some of the realities, we all get very excited, myself included, about technology. But the reality for embedded systems is that more than 80% of embedded systems, if you don't count people who embed PCs and PC boards, are on 4, 8, and 16-bit microcontrollers. Of those, more than 75% of them have less than 16K of code space, and more than 90% run without an OS or without an API on board to program. You are really programming to the chip level, but programming for the system. Connectivity is coming, and it's exciting, but it's not the norm. Cost is still king for many customers. The difference between a 14-pin chip or a 20-pin chip is, for a lot of our customers, incredibly painful. And embedded systems design is, the good news is that embedded systems design is one of the engineering disciplines that's much harder to source offshore because you're not designing to an API level, you're not designing to an OS that everybody knows. You're making a machine move or do something that you really need to have the people who are in charge of the product present when you're making some engineering decisions. Who are we? We are an engineering consultancy. We're 14 years old. Our concentration is embedded systems, but we also do power and battery systems as well, which, interestingly enough, now most often include some kind of embedded firmware for one reason or another, whether it's power factor correction, whether it's just to simplify some things in the system that are now more complex to do in hardware than in software. We get involved from the beginning with some customers doing technical marketing, so specifying products and what technologies are used, all the way to full product design. And for some of those customers that were dragged kicking and screaming, we even produced PC boards. So we see the full process in a number of different industries. We're a Platinum Alliance partner with Renesas, so we are very familiar with their product line and work with a lot of their parts. We serve multiple market segments. The company that I founded 14 years ago has taken the same path that my career did. Every time I changed jobs, I changed industries. And so we right now are working on a battery system, 2 medical products, 2 LED lighting solutions, something that's going to fly in a helicopter, and a motor control and a temperature control device, and a cooking device for a consumer products company. So we see a lot of different things in a lot of different industries. It's actually helped us out a lot. Depending on what management book has come out recently, benchmarking is really important. So people think because we worked in and it's true, because we worked in the toy industry last week, we can use some of that knowledge to solve a medical problem this week. We and our clients are the people hiring the engineering graduates in embedded systems. Our typical customer is a small to medium-sized company. We're not supplying the car companies. We're not supplying General Electric. We are typically in the under $100 million company, or under $300 million company for our customers. Renesas is a company that's based in Japan. They are probably the largest semiconductor company you may never have heard of. They are the largest supplier worldwide of 8 and 16-bit microcontrollers, and they have been formed over the last number of years with a combination of Hitachi, Mitsubishi, and NEC's microcontroller families. They also have a broad line of power devices and other peripherals, so they see many parts of many industries. Why is embedded different? The systems have gotten so small that understanding how individual chips work and their functions is no longer key to the solution. The key to the solution is understanding how the system works, so designing from the system downward. Very often it's just a microcontroller and a handful of passive components, or maybe a transistor here or there. It's not enough to just know how to program registers, how to use an I/O port, what the voltage limits are. Cost reduction comes from overall creativity, not just software. And what do I mean by that? It used to be that you could look at a system and say, well, I can do these 5 things in software and I can remove some parts. Sometimes rethinking the entire system and how it's implemented can produce a tremendous cost savings for a customer. I interview a lot of students to come work potentially for BNS Solutions and also for some of our clients. One of the things that we do with our clients is help them in the interview process, because many of them don't have the engineering expertise. That's why they've hired us. I've been doing internet security for 4 years. I should be able to do embedded systems with no trouble. It's incredible the number of people who think, because they've been working on incredibly complex problems, that making something that looks simple is a simple task, and it really is not. How many gigabytes is available on the system for the programs that we write? You should see the looks when I say it's 2K of code space. You could usually replace them with an actual deer caught in the headlights. What's the OS or API? It simply doesn't exist. Are you using C++, C#, or Java to program the system? My web design and database background should be invaluable to you. This is someone who should be in in enterprise computing, not in embedded. This is not uncommon. This is the toaster that is on my kitchen counter. It has a small controller in it. It has an LCD display. It has a knob and a bunch of buttons to do everything from decide which elements are on to whether you should abort the process early and reset things. It has a little countdown thing, which you can see from the other side of the kitchen, which has been great in the morning when we're trying to get everyone ready. But it's a microcontroller, and it's toasting bread. So that's not atypical of our customer. But it produces some interesting challenges in the industry for these small systems. I have 1 free pin and I need to connect 4 switches. The typical solution that I hear when I work with young engineers on this is, why can't we just use the next biggest part? There's more pins. I need to run a PID control algorithm and I have 2K of code space and I'm only running at 4 megahertz. And they are trying to do integral calculus. So that just doesn't happen. I need to average the middle 80 12-bit A to D conversion samples out of 100, but I only have 128 bytes of RAM for storage. So immediately you know that you can't take 100 samples and then find the 80 middle ones. I have 2 pins left and I need to drive 1 of 3 LEDs. So I have to have another pin. Well, no, you don't necessarily. Other things. How do I drive an LCD display without an LCD controller? The number of times that we implement displays without specific hardware and even motor control and things without specific underlying hardware is a challenge. How can I simulate animation on a segmented LCD? My customer wants to see wants to show their customer that something's moving, but all I have are segments on a custom LCD. Why is my circuit board so noisy? PC board layout is something that we don't really teach a lot of, and certainly I think that there's a lot of stuff that it gets simulated, and when the student goes to actually implement it, when they get out into the real world, it's not quite the same as what they were expecting. How do I generate 5 volts from 120 volts without a transformer? This one is always a lot of fun, because once we do it, nobody wants to touch the circuit anymore. How do I calibrate an analog channel in production? You know, we can make anything work in the lab, but when a customer says, I need to make 150,000 of these a year, and they all have to be good. Most recent engineering graduates we encounter are incredibly bright. I have to say, I love my Gen Y employees, and I wouldn't trade them, and the ones that we work with, and I wouldn't trade them for anything, but they are so laser focused on the things that they learned, that they have a great depth in that field, but they're not ready to enter the mainstream embedded design space and address the challenges that I just talked about. There are plenty more. This is even more critical for small companies that don't have backup resources. If you've got training programs in place, if you've got mentorships within the organization, you can grow your young engineers. But a lot of students come out and go to work for small companies, and they are the only or one of 2 resources, and really need to take responsibility for things that they wouldn't normally in a larger company. I say the generalist is dead. They're not really dead, but they're certainly not the generalist that there was when I graduated. Frank Zappa said, jazz is not dead, it just smells funny. That's sort of where we're at. There are a few people who were hobbyists before they became engineers, and they have some general knowledge. But watching some of these guys run a drill press is the stuff of which YouTube was made. Things that I hear after 1 year of working in this space with us, either at BNS or with our customers. I look back at my senior design project and I just laugh. Understanding the system has made my engineering knowledge more valuable. Thinking at the system level, I'm making better engineering decisions. I thought marketing was BS until I started working directly with customers. This is a big one, because as engineers, we really value the knowledge and the discipline and the exactness of what we do, and look at a lot of the other company divisions or departments as just sort of required to be there. But when you work with someone who really understands their market, and they have an understanding for what they want a product to do, and convey to the engineer the cost challenges associated with it, you get some real creative results. My friends have been working as long as I have and haven't written a line of code. We take someone who's out of engineering school for 6 weeks, and they are writing code that might very well be on the shelf in Walmart 6 months later. They are right in the thick of things and have really worked on things that they will see, whether it's something that's going to fly, or whether it's something that's going to save a life or make a medical operation faster or easier or more exact, or something that it just is a consumer electronic. How can we address the problems that we see? We have gotten together with Renesas. They approached us as a Platinum Alliance partner and said, we want to address the universities and have a university program that is different. What can we do? You see a lot of places where these engineers graduate and enter into the workforce, and what should we be doing? And we said, you guys are chip companies. You are not circuit board companies. When you try to make a circuit board, you try to make a circuit board that does 100 things because you only want to make one, because you make chips. And that's what you do. We look at that a little differently and look at some areas where some targeted hardware, where you can look at an overall design and see exactly how every part of that design plays into the solution is very important. So together with them, we've designed a series of embedded systems learning kits that stress real-world situations and design trade-offs. We have a multi-level learning set up for full curriculum throughout higher education, so starting with simple microcontrollers and simple systems, and working all the way through to that internet connectivity and internet security if the curriculum goes that far. We've dedicated kits to solutions, not just technology. So you start with a general purpose kit where you can do a lot of things, but then there are some things that focus on specific technologies. Renesas has a very large ecosystem. There's a Renesas Rules website. If you've never been there, just you can get to it right from the Renesas site, or if you Google Renesas Rules, it'll bring you there. It is monitored by members of Renesas staff as well as some university students that are chartered with addressing some issues, and also people in my organization and other industry people. There is a formal Renesas University program. We, as an engineering company, are involved in that program, both working with the educators, working with Renesas, and even supporting and building the kits. Renesas is supplying uncrippled design tools, full optimization, full compilers, and there's a limited code space, but everything that we do fits inside that code space. The design kits include hardware, the tools, example designs. There's course material background for universities who want to build their own programs. The kit pricing ranges from $49 to $99 depending on which kit and what you want to do, and all the kits are available directly through DigiKey. This was the first one from a couple of years ago. It's an M16C 62P, which is a 16-bit part that Renesas has. It comes with a display. It has some connectivity to the PC. All the emulation tools are built right onto the board. It works directly out of the box with their software and comes with their full design suite. They have a new line of small to medium-sized microcontrollers, the RL78. This one has an RL78 on it, a graphic display, some input and output circuitry that's right there. Again, the emulator, the debugging tool is built right onto this. You can power this right from the USB if you wanted to, or have it run standalone with a power supply. The RX63N is almost the largest part that they make, and it has, as you can see from the photograph, it has Ethernet connectivity, it has USB connectivity, it has RS-232 and 45 connectivity. It has the little wheel near the bottom is actually motor simulation, so you can write some motor control code and see if it spins. Other solution kits, embedded segment LCD design. We have designed a segmented LCD and works with one of the LCD controller devices, but is also connected to general purpose I/O pins, so the students can see how to work directly with digital I/O or with on-chip peripherals. Temperature control loops. This is a very interesting full PID if you want, or bang controller. There's actually a heater and a little place that you can melt an ice cube, and you can take temperature measurements and see how your PID responds as you, or your control loop responds as you tune it. BNS and Renesas and E-Ink have teamed up to teach people how to use E-Ink displays. This is the display that's on the Kindle and a number of other e-readers. Those are matrix graphic displays. They have a series and are expanding a series of standard and some custom segmented LCDs, displays using the same technology. And this is a kit that actually shows you how to drive those displays. You get a series of displays, you get the processor and all the code to make that work. There's a motor control kit that teaches about motor control, and embedded communications. And for a lot of our customers, we are a big proponent in having multiple microcontrollers in the system, because you can get a product out to market faster, and in those cases where the volumes are low and the cost is not paramount, you can get a product to market much faster and maximize, the customer can maximize their profit in that way. So we look at how to interconnect ICs and also do some PC connectivity. I just want to end with a very exciting announcement. In talking with Renesas, we are going to do a Train the Trainer session in the BNS Training Center up in Massachusetts. It's going to be 4.5 days of training that is in our 12-seat. We have a 12-seat theater-style training center. And there'll be interactive sessions with industry engineers. We'll be training on the kits, on the tools, and talking about industry problems. You get a chance to meet some of the guys who I've hired and some other people in the local industry, as well as some technical people with Renesas. And the first 12 professors adopting the Renesas kits for their program will receive some amount of expense reimbursement, and we're working through all of the details on that. So we can send you a link to a website that'll tell you more about those. Here's some contact information on Renesas and us, and we also have an expo booth, so come by. We can talk about the solutions to some of those challenges that we talked about and how we actually solve them. You can see some product that we've designed for various customers who've let us bring them here, and thank you very much for your attention.